Welcome to the Autoflight lesson in the PMDG 737 NGX groundwork from Angle of Attack. In this lesson, we intend to shed light on the following topics: Automatic Flight System, or AFS, Autopilot Flight Director System, AFDS, Mode Control Panel, MCP, Flight Director, Control Wheel Steering, Yaw Damper, and Auto Throttle. Before the lesson started, it's worth mentioning that the Autoflight system as a whole is very complex. If we were to cover every detail here in groundwork, it would be the largest section yet done. Our team put our heads together to decide how to best teach this large subject that is autoflight. We determined that the best course of action would be to teach you most of the material during flight work while we're doing the procedures and going through the progression that would show you the intricacies of each function. Finishing off groundwork with sections on autoflight will properly transition you to flight in the aircraft as we fly the procedures. For now, our main purpose is going to be all of the system's background information that's being passed along, and the different components that are in play while you, the pilots, are turning knobs and flying your flight's correct profiles. If all this sounds confusing, it's because it actually is confusing. That's why learning the system components first, then learning about the flight modes is so essential at this point. We hope to simplify this complex subject now so that you can enjoy the aircraft once it's time to fly. The Automatic Flight System, or AFS, is a suite of different components that allows the pilot to get guidance through indications on the displays, or the ability for fully automatic flight. No one component acts on its own to control the others. Rather, it's a digital, analog, and mechanical symphony that allows for smooth, efficient, and automated flight control. Everything else we talk about in this autoflight lesson will be assumed to be encompassed by the overall subject of the AFS. Consider AFS the mothership of autoflight. For simplicity reasons from here on out, we'll refer to AFS as simply autoflight. Flight Control Computers, or FCCs. The brains of the entire operation lies with the Flight Control Computers, or FCCs. The FCCs take information from all the different components and through a tremendous amount of data from various sensors and systems, sends that information out again to continually keep the system running harmoniously. Consider the FCC to be the conductor of the symphony mentioned earlier. Without the FCC as the conductor, all the components would be off-timing and off-key, if you will. There are two FCCs located on the 737 NGX. These are referred to as an A and B FCC. Each FCC has its own set of 16-bit processors. Each processor calculates different functions of aircraft operation. This is a visual representation of what components interact with the FCC, which also lays out most of the components of autoflight, since all components interact with the FCCs. Under Auto Flight Control Column and Control Surface Movement, we have Control Column Force Transducers, Aileron and Elevator Actuators, Stabilizer Trim Electric Actuator, and Mach Trim Actuator. Under Displays and Warnings, we have the Common Display System, Aural Warning Module, Autoflight Status Annunciator, and Remote Electronic Unit. Under Sensors, we have Control Position Sensors, Switches, Nav Sensors, and the Air Data Inertial Reference Unit, or ADIRU. And finally, the components that we spend the most time interacting with. These components, which we'll talk about in the next section, make up the AFDS, Autopilot Flight Director System. The Mode Control Panel, MCP, FMCs, which are Flight Management Computers, and the Auto Throttle. The vast majority of these sections we won't be discussing directly in this lesson, but we'll cover some of them now. All that said, from this image, you can tell that the FCCs take a tremendous amount of information, sort through that information, and send it back out as needed. Again, it can't be stressed enough that without this essential central hub, which we referred to as the conductor of the symphony, these components wouldn't have a way to communicate. It takes a central location for processing to make sure that the information input by the pilots to the MCP, autothrottle, and FMCs turn into control movements, smooth automated flight, and successful navigation. The real kicker that jumps out is that the computers themselves are nothing special compared to today's computers. Although they are undoubtedly very sturdy and robust in their ability to withstand a lot of environmental conditions beyond normal home computers, they are vastly underpowered even when compared to a smartphone. If the FCCs are the brains of the operation, the AFDS is the management. This is where, as pilots, we choose which autoflight mode the aircraft operates in with the MCP, what automatic power settings the engines are commanded to with autothrottle, and also if we choose to use the complex FMC system to use various AFDS modes. Although technically the FMC is not part of the AFDS, we include it here because it's tightly integrated with not only the AFDS, but the FCCs themselves. A flight could be performed without the use of the FMC, but it wouldn't be economical for the operating airline or efficient for the pilots flying. We consider the FMC to be an integral piece to the Autoflight puzzle, which is why we've dedicated a whole section of groundwork to it, and why you'll see extensive operation with the CDU, Control Display Unit, in the flights we perform as part of your overall 737 NGX training. The main means of interacting with the AFDS and FCCs is through the Mode Control Panel, which we'll call the MCP. This is a panel that you'll learn to be intimately familiar with as you progress through flight work and line work. One philosophy of Boeing that differs from other aircraft manufacturers is the ability for total pilot control at any time. Although the 737NG is not at the technological pinnacle of the Boeing aircraft line, with a complete fly-by-wire system that has some pilots on edge, the same philosophy of pilot interaction and control, very much seen in action with the MCP, is seen in all 700 series aircraft to a varying degree. Some of the functions of the MCP, to name an important minority, are engagement of the autopilots, turning on the flight directors, selecting the mode of operation, arming autothrottle, selecting course and heading, and selecting target speeds and altitude. Now, it's actually not that simple and easy when it comes to the MCP. There will be much more to come as we're flying later, as mentioned many times during this lesson. Our goal in teaching you about each component on the MCP later on in this training is to instill healthy verification habits of the selected mode, the indications that should appear, and what should happen as a result. Although highly unlikely that the Autoflight system would actually do something out of the ordinary, this places the operating crew in a constant state of awareness about what's selected and indicated. Just as checklists are essential, we'll also be verifying and checking that the commanded MCP modes match up with FMA, or Flight Mode Enunciator, indications. The MCP's communication with the FCCs, and therefore every other component of Autoflight, is uniquely tailored for each flight mode that the aircraft is in. Each mode, as you look across the vast options on the MCP, has a different set of commands that the FCC sends to the Autoflight actuators, or displays to the pilots via the flight director and instruments. This system as a whole is useful to the pilot flying in different ways. The first type of display and commands we'll talk about is the flight director. The flight director is essentially an FCC data-driven display on the primary flight display, or PFD. Some call these the flight director bars, but they can also be displayed in a wings format. Depending on the mode selected from the MCP, the FCCs send the information through various components to then be displayed for the pilots to follow. flight directors are turned on from the MCP, both on the captain and first officer side, as each side has its own independent flight director system, which communicates with their respective FCC. Now, flying with the flight director is a fully manual mode for the pilots. At this time, the autopilot is not controlling the aircraft. Rather, the same system that tells the autopilot control actuators what to do is simply displaying that data to you, the pilot, so you can follow the commands yourself. In fact, the autopilot can be engaged with the flight directors in the off position, although this kind of situation is rare because of operating procedures that both we and the vast majority of airlines use, meaning flight directors are turned on at some point during the pre-flight and will remain so until at your destination. FCC data used for commands to the flight director and the autopilot system are actually filtered differently. The commands you see on screen when flying with the flight director is not the same data the autopilot uses. The autopilot data is more filtered, detailed, and looks ahead to a greater degree. In certain situations, for example on takeoff when autopilot isn't available, the flight director is available. Although takeoff is largely a visual maneuver, the flight director will give commands until the autopilot can take over at 800 feet AGL. We'll be using the flight director often in all hand-flown situations when we're in flight work and line work, where you'll learn to become very familiar with mode selection via the MCP and autoflight guidance via the flight directors. Autopilot operation in and of itself is pretty simple when one can gain an understanding of the flight director. It appears as though the autopilot is simply following the flight director commands once engaged. However, as mentioned before, the actual data used varies a bit. Regardless, once you gain an understanding of the MCP mode selection, the modes displayed on the flight mode annunciator, and the fact that the flight director is giving you commands to follow these modes, it's easy to understand that the autopilot, in basic form, does the exact same thing. Autopilot, in the most simple explanation, simply follows the flight director commands. It's like you, only automatic and better at flying the airplane in most situations. However, there is a between mode that is often forgotten. This is called control wheel steering. For those of you familiar with our MD-11 training, you know that aircraft has a system called the LSAS. Essentially, the pilot doesn't have to trim. The pilot simply places the vertical target where desired, and the system will adjust automatically and keep that pitch attitude. Control wheel steering, although an arguably simplified version of the MD-11 LSAS, can hold pilot-commanded roll and pitch. Unlike flight director, the autopilot actuators are working to keep the flight attitude the pilot has set using the control wheel. However, unlike the autopilot, the system will not follow continuous changes. It's a set it and stay command. Just imagine, if you will, telling your airplane as you would a dog, sit, stay. That's what CWS does. It won't move, it won't adjust, it simply stays put. In an actual example, although the MCP is set in heading select and level change, the pilot can only set where he thinks the aircraft should go to hold that setting. If a variable changes, say airspeed, wind direction, and so on, the FCCs will undoubtedly make some minor adjustments to what it thinks should be done. The autopilot would jump on those commands and make the adjustments, or it would be reflected through the flight directors. Control wheel steering, however, remains in the same commanded position. Sit, stay. View it this way. Flight director is continually adjusted manually. Control wheel steering is periodically adjusted manually and held automatically. Autopilot is fully automatic. Much of what you're learning here is literally seeing is believing. That's why we've chosen to cover most of the topics in the aircraft while we're flying. Once you see what it does, you'll understand. Just as with the flight director, we'll be showing you a bit of the control wheel steering capabilities of the 737 NGX during our flights. A few topics remain for this Autoflight lesson that, if not explained now, will likely slip through the cracks. So we'll discuss the yaw damper and auto throttle systems in quick succession in the remaining minutes of this video to give you an idea on why they're essential and how they fit in Autoflight. As the aircraft moves through the air, it's not only constantly working to overcome the forces acting upon it, but it's also working against environmental conditions like turbulence. Turbulence and Dutch roll are the reasons that yaw damper becomes such an essential system for jet passenger aircraft. This started with the first large jet aircraft being used to fly passengers back in the golden years of passenger service. Yaw damper essentially keeps the aircraft continually coordinated above the vertical axis, eliminating unneeded yaw. This not only keeps the aircraft flying smoother, but also keeps the passengers comfortable. Otherwise, you'd have a lot of people getting constantly wobbled about by Dutch roll. Many would be surprised yaw damper does belong in this lesson, as it is an Autoflight subsystem. It's dependent on the sensors that are a part of this system, and it also looks ahead to smoothly transition from one control movement to the next. Yaw damper is generally engaged prior to flight on the overhead panel, on the flight control sub-panel. This is generally part of the pre-flight flows, which you'll learn later on in the training. Yaw damper is also indicated right above the standby instruments, captain's side of the main panel, just under the glare shield. Now onto the subject of auto throttle, our final subject. The auto throttle is tightly integrated with Autoflight to ensure that by whatever mode the pilots wish to operate in, selected of course on the MCP, the flight control computer A, in this case, and the auto throttle computer can send commands for thrust output. All commands from the auto throttle computers move down the line to eventually show the physical movement of the thrust levers on the control stand, in addition to showing indications on the displays that reflect the thrust being output by the engines. Auto throttle is armed on the MCP. From the MCP, not only is auto throttle armed for Autoflight modes, but there is also direct control of thrust through the speed and N1 modes on the left portion of the MCP. When in N1 or speed modes, auto throttle is not controlled by any other part of the Autoflight system apart from its normal communication with the FCC, thrust levers, and therefore the engines. Whereas, as you'll see later, if the aircraft is commanded and flying in vertical navigation mode, the flight management computer essentially requests the specified numbers and therefore thrust setting that it needs. This is indirect control through the FCCs to the engines eventually. On the thrust lever is also a take-off, go-around, or TOGA switch that selects either the take-off or go-around modes directly from the thrust lever. The idea here is that the pilots can keep their hand on the thrust lever at all times during those critical phases of flight. During the course of our flights, we'll be discussing the auto throttle indications. For the most part, however, apart from the engine indications and the flight mode annunciator, most of what the auto throttle does is transparent and simply takes the thrust numbers required by the various modes and does its best to deliver that thrust from the engines in a smooth manner. EEC, electronic engine control, is the last component that the auto throttle uses. Although not part of the auto throttle system, the auto throttle system still uses EEC targets to set thrust for takeoff, climb, and max thrust go-arounds. These are fairly aggressive modes that require monitoring to ensure the engines are kept within good working order and protected from undue wear. As you've seen during the course of this lesson, the Autoflight system is a vast subject that we've only scratched the surface on. The overall focus of all of our flying in the aircraft, that is time spent parted from Earth, will be interacting with some or all of this system. You'll be fascinated by the intricacies of this system as we finally get up in the air. In this lesson, we covered the following topics: automatic flight system, or AFS, Autopilot Flight Director System, AFDS, Mode Control Panel, or MCP, Flight Director, Control Wheel Steering, Yaw Damper, and Auto Throttle. In the next lesson, we'll be talking about the Flight Management System. Although not a completely separate component of the Autoflight system, it deserves its own detailed lesson. Until then, throttle on!